This section is Topic 1, Section 2, Attributes of Functions. There are several key concepts inside this that we need to know, and that's the key vocabulary terms. X-intercept is when it crosses the x-axis. That's marked in red in the bottom of the graph. The y-intercept is where it crosses the y-axis. That is marked in blue on the graph. Asymptote is a line that the graph approaches but does not cross. It will never cross nor touch that asymptote. It has asymptotic behavior, is the trend towards that asymptote. Maximum is the maximum value over that interval, and it can be your maximum y value. It will be your maximum y value over that interval, and the minimum is the minimum y value over the x interval. Symmetry is like a butterfly. It's where you can fold it in half and it looks the same on both sides. Or it can be rotated in half and carries the graph onto itself. A graph that has a rotational symmetry is going to be your x cubed graph. If you'll type that into y equals on your graphing calculator, you can see that if you were to twist quadrant 1 into quadrant 3, it would be the same. Let's practice graphing a function. You should have already, this would be very similar to what we've done before, except for we did not have the f of x then. We were using something instead called just using a y. It works the same thing. We're just writing it inside function notation, just saying this is a special type of relation called a function. So my y-intercept is going to be this 2. It's a positive 2, so I go to positive 2, and I am going to mark it with a dot. Now, since my scale is 1 square, each square is 1 by 1, I can actually do the rise over run to help me find my next point. Or you could do a table of values, or you can use your graphing calculator to help you graph these. So I'm going to use my slope to help me find the next value. And so that slope is marked here. It's negative, so that means I'm falling from my y-intercept. I'm going to fall 2, run to the right 3. Or you could have gone up 2 and back 3. And I want to draw in my line. This line, even though I just show it going in this quadrant, in this spot, it actually will continue on forever in both directions. And so if I was to need to give my domain and range in interval notation, my domain is from negative infinity to positive infinity, because this graph will go on forever in both directions. My range is also from negative infinity to positive infinity, because it will cover all the y values throughout the process of graphing. Let's look at a new function. F of x is equal to negative 2x plus 7. This is a restricted domain, and it means we are including, we're going from negative 3 to 10, all inclusive. That means we include the point at negative 3 and we include the point at positive 10. For the purposes of the first two questions, we are not worried about the restricted domain. So the domain of f of x, because it's a linear function, is going to be from negative infinity to positive infinity. The range is the same thing because this is a linear function. If you have a quadratic equation, your range will not be from negative infinity to positive infinity. It will be based upon your vertex, and you'll restrict your domain. So it's important, while you're reminding yourself on how functions look, if you can't remember how that function appears, use your graphing calculator to graph some of these functions and see what values it may not cover. We will go over tomorrow in class some key attributes from special types of functions using your graphing calculator. Now, let's find our range with the restricted domain. This is going to be a straight line, so if I find my starting point on that domain, so if I find out what f of negative 3 is, then I know one of my points for my range. So negative 2 times negative 3 plus 7, so positive 6 plus 7 is 13. That's one of my two values. The other value is f of 10. I'm going to draw a straight line down this so you can see the difference between where I'm at. And so f of 10, I have negative 2 times 10 plus 7. So that's going to be negative 20 plus 7. This is giving me a negative 13. So my two endpoints on that domain are positive 13 and negative 13. To give my range, I am going to mark my range. Range is from, now we always start with our smallest value, so our smallest of those two values is negative 13. And I can be at negative 13, so I use that set bracket, the square bracket, to help show that. And then I will end at positive 13. Tomorrow, don't forget to make notes of this, because tomorrow in class we're going to be doing some similar equations, as well as we're going to look at a couple of other functions just in our graphing calculators as a class.